Hello and welcome to Edu-Malanga. On Edu-Malanga, we make free tutorial videos for the Matric Mathematics syllabus of South Africa. Today we are introducing the last sequence under the first unit of the year. The sequence I will be introducing you to is a quadratic sequence. Quadratic sequences live under the first topic of the year, which is patterns, sequences, and series. So let's get right into quadratic sequences. We've looked at two other kinds of sequences on this channel. We looked at arithmetic sequences and geometric sequences. The quadratic sequence is similar to the arithmetic sequence, but the quadratic sequence has a common, so there's a common difference here as well, a common difference, but it is the second difference. So let's get started, for example, and build our own quadratic sequence so you understand. We'll start by picking the second difference that's going to be common. Let's pick an easy number like 2, then we'll have 2, and we'll have 2. So this is the second difference. We'll call it D2. Let's come up with the first term for the first difference. Choose, for example, 6. This will be D1. So 6 plus 2 would give us 8. Okay. And 8 plus 2 would give us the number 10. Yes. 10 plus 2 would give us the number 12. So this is the first difference. From here, we then get our sequence, which will be Tn. The same notation that we've been using for all other sequences, and we'll pick first term, for example, negative 2. So negative 2 plus 6 gives us the term 4. 4 plus 8, that's equal to 12. 12 plus 10 is 22, and 22 plus 12, that's 34. So our sequence, which is the quadratic sequence, is equal to Tn equal to negative 2, 4, 12, 22, and 34. This is our quadratic sequence. So the general term of a quadratic sequence, we're not going to derive it because that would be very complicated, but I'm going to write it down and then explain how we solve for the variables. The general term for a quadratic sequence looks like this. We have Tn is equal to a times n squared plus bn plus c. So it's a quadratic equation, and that's why we call it the quadratic sequence. Just to avoid any confusion, let me make it clear that a in this equation does not represent the first term. It's a coefficient of n squared, just like b is the coefficient of n, and then c is a constant. This is just the quadratic formula. These are the coefficients. This is not the first term. When we're looking at quadratic sequences, our first term, we will just call it T1. So how do we solve for the coefficients that go into this equation? There's three equations that we use, and the first one solves for a. Let's write it down. 2a is equal to d2. So when we're solving for the coefficient a, we will then have that a is equal to d2 over 2. So this is the first equation that allows us to solve for a. We then solve for b using this equation. 3a plus b is equal to term 2 minus term 1. This is their second equation. We start off by solving for a, and then we substitute a into this equation, and then we solve for b. And once we've solved for b, we solve for c using a third equation. And the third equation looks like this. A plus b plus c is equal to 1. These are the equations that we use to solve for the coefficients of the quadratic equation. for our quadratic sequence. I know it's a bit of a lot to take in, but let's use this sequence that we made up as an example, and let's solve for the coefficients a, b, and the constant c. We can come up with the general term for this quadratic sequence. So the first thing we will solve for is a. Let's call it step 1. So we know that we start by solving for a, and let's remember 2a is equal to d2. Let's look at our d2. Our d2 is equal to 2, correct? So we will say d2 is equal to 2. So therefore 2a is equal to 2. If we divide by 2 on both sides, everything cancels out, and we get that a is equal to 2 divided by 2, that's equal to 1. We've now solved for a, and then the next step, step 2, we will now solve for b using the equation 3a plus b is equal to term 2 minus term 1. Let's start by solving for term 2 minus term 1. We'll say term 2 minus term 1, that's equal to, come back to the quadratic sequence. Term 2 is 4 and term 1 is negative 2. So we have 4 minus negative 2, and that's equal to 6. From here, we know that a is equal to 1. We solved for it. We'll substitute everything in then. The equation becomes 3 times 1 plus b is equal to 6. If we subtract 3 from this side and subtract 3 from this side again, we get that b is equal to 3. That's the end of step 2. We've solved for b. And then we come to step 3. Step 3, we solve for c using the equation a plus b plus c is equal to 1. A we solved for and we found to be 1. B was equal to 3. Let's substitute these into the equation then. We have 1 plus 3 plus c should equal to 1. 1 plus 3 is 4. We then get 4 plus c should equal to 1. Let's subtract 4 from both sides of the equation. Minus 4 on this side as well. We then get, the 4's will cancel out, get that c is equal to 1 minus 4, and that's equal to negative 3. Now that we have solved for all the coefficients, we may substitute them into the quadratic equation, and it'll become Tn is equal to, a was 1, so n squared plus b was equal to 3, 3n, and our c we solved for is minus 3. And this is the general term. Quadratic sequences are a bit different to the other sequences that we solved, but I hope you understand everything that we've done today. I'll do one more video with one more example on quadratic sequences.